Okay, for 4-5 solving rational equations, we have added, subtracted, multiplied, divided, and those are all the things we have to do to be able to solve, correct?
Yeah.
So that's what we're doing next. Okay, so we need to solve. Solve 2 over x plus 5 equals 4. Write it down. I know it's been a long weekend, but I think you all know how to take notes.
No.
Okay, so how do I start? I don't care if it looks funny, if it looks bad, if it looks horrible to you. How do I have to start? Yes? No?
Just make you call me.
Yes?
You multiply x plus 5 over 4.
Yes. We have to multiply both sides by the x plus 5. So we have x plus 5. And then on the left, it would just reduce out, wouldn't it? We're kind of cutting it short. Doesn't matter what it looks like. If there is a denominator, I have to multiply it over to the other side, don't I?
Yes.
Got to do it. Now what?
You distribute.
Distribute. So 2 equals 4x plus 20. And then solve it.
What's this?
Yes, sir.
I have the answer.
So do I.
How'd
Is
you
it
get-
that one?
I have the answer.
How'd you get that? -9 over 2.
Okay, what did you do, Cooper?
I got to the -18 equals 4x. Just
And then what did you do?
left it.
What is 4x? What math is
4
4x?
doesn't go into.
Right, it doesn't. And the world is no longer whole numbers. So 4x is multiplication, so I have to do what? Divide. So 18 divided by 4 is 9 halves.
Oh, I see.
Yeah.
I see now.
Yes.
So I brought the 2 over, and then I got positive 18.
So you divided.
Then you would have negative 4x. Because you have to have the x on one side. Like-
Oh, okay. I guess I didn't realize I had to have it. Like, they could be together.
Yeah. What, Cooper, did you say?
I said so you just divided both of them by 2.
Mm-hmm. I reduced. Okay. Try the next one on your own.
I don't really feel like
And that one.
Good for you. Can I start?
That's a negative.
This is basically This is easy.
What's a negative?
oh crap. Keep putting this backward.
Add it
please,
over.
It's a
Nick.
negative. Bro. Yeah.
Audibly said bro.
Guys, we don't discriminate here.
Okay, Cooper.
Okay, we're all trying to learn.
Shh. Cooper, we're back to our following our algebra rules. I got to add it over. Yes? And then I have to divide by 5. I'm leaving out those middle steps. Am I still showing my work without showing every little step? What I'm trying to model to you guys is you have to show me something, but does it have to be every little thing like it had to be in Algebra 1? No.
Yeah. No.
Right. I want you to show work. I want us to show what the necessary work is. Does that make sense? Because we're going to get to the point where we have a problem that's huge, like 10, 15 steps. And if you're showing every little step, you're going to make your, like, so long, it's going to be overwhelming. Cooper, does that make sense now that I went through it? Are you just shaking your head just to shake your head? Okay, I'm going to torture you next one. You ready? Okay.
Good lord. Do you have to times?
Really, Miss May? Was it really necessary?
Okay. Yeah.
Well, wait.
No. Go ahead, Olive. What's your idea?
So the equal sign, doesn't that just kind of like create a little variable?
Yeah.
So can't we get the common denominators for the 1 plus x, 1 over x minus 5 plus x minus...
It's exactly what you have to do. She's saying we need to put these into one thing, and then would we multiply over by the denominators? We do cross multiplication. So we need to do common denominators. I am going to give you a very, very huge tip. Pro tip here. Find a common denominator for the whole problem. Okay? So if we were to do that, we're going to treat like this is just like a plus. Okay? It doesn't matter. Well, I'm not going to do that. We just need a whole thing. So this is x minus 5. This is x minus 3. So what do we need to do with this one to check out what it is? No, but what do we need to do with the polynomial to get common denominators?
Something.
Wait.
Factor.
We need to factor it.
You can factor that?
Well, factors of 15 that add to 8.
Oh.
3. Negative 5, negative 3.
Okay. So I have x minus 5 and x minus 3. So there's a couple things. We can get common denominators or we could just multiply over and distribute. Let's get common denominators first, okay? So my common denominator is going to be x minus 5 times x minus 3. And I'm not going to do anything over here to the right-hand side. I'm just going to leave it. So what do I need to multiply this fraction by? Sam, did you say it? X minus 3. And what do I need to multiply this fraction by? X minus 5. So that gives me what? X minus 3 plus x squared minus 5x. Okay. Now, we're going to arrange that and we're going to make it all nice and pretty, but I'm going to wait. Because now I have a denominator on both sides, so I need to multiply. I need to cross multiply, don't I?
Yeah.
Yes? But I have a question for you. If I multiply this by x minus 5, x minus 3, and I multiply this by x minus 5 and x minus 3, what are my denominators on both of them going to do? Reduce to 1, not 0. So if I can get a common denominator across the whole thing, did I just give myself not a problem? It's a fraction.
Yeah.
So that's my pro tip. Get a common denominator for everything and your denominators reduce out. You've essentially moved the numbers from the denominator to the numerator by getting the common denominators. So I now have x squared minus 4x minus 3 equals 2. Now we're back to chapter 3.
What? Did you not multiply yet?
They reduced out. I can't factor till it's equal to 0. So I need to subtract over 2.
Yep.
So x squared minus 4x minus 5 equals 0. Now I have to factor. I told you, I promised you factoring would never go away.
5 minus 1.
So x minus 5, x plus 1?
No, x plus 5 minus 1.
No.
Oh, wait, my bad, sorry.
No, Olive.
Okay, so x equals what?
Positive 5 and then negative 1.
So negative 1, positive 5?
Yes.
Okay, I was like the negative first just because I'm weird. Like smaller to larger, but it's the same thing, right? 5 and negative 1 and 5, same thing. So after I got here, above it is topic 4. And down here was topic what? 3. So we're just putting everything together. So it looked like it was harder, but was it really?
No. Is that what 5 and
Yes,
6
that
look
was incredibly.
What?
like? Is that what 5 and 6 are gonna look like?
Probably. Okay. So 1 over x plus 2 plus 1 over x minus 2 equals 4 over x squared minus 4.
Oh, well, this one's easy.
Yes, Alex?
Can we take the negative out of the second equation? Yes.
Out of x minus 2? Why?
Well,
What do you think it's going to do for us?
you know what? Now that I think of it, nothing.
No, it's not, I mean, we can take it out, but then we'd have a negative x, and that wouldn't help us, right? Okay, so the left side, to me, both of those fractions, the denominators look pretty factored, don't they to you?
Yeah.
So what should I do on the right side to the denominator?
Factor.
Factor. And that is a difference of squares, correct?
Yeah.
So
X minus 2x.
x minus 2 and x plus 2. So I can multiply both sides by what?
X minus 2,
X minus 2, x plus 2. Oops. Are you guys going ahead on your own? Cooper, help me out. What do I need to multiply this? Which one of these is going to work? Because like the x plus 2 and the x plus 2 is going to reduce out, right? So what's going to be left?
X minus
X what?
2. Minus 2.
So x minus 2 times 1 would just be x minus 2. Oops, no parenthesis. Okay, and then when I do it over here, with this one, it'd be x minus 2, x plus 2. So the x minus 2s are going to reduce out. I'm left with x plus 2. Oh, this, I should not have written my denominator, should I?
No.
Because it's going to reduce out.
Yeah.
So now what do I need to do? Subtract the 4. Why do I have plus? Oh, I think I have x squared. Oh, I'm not going to subtract the 4.
Mom.
No,
You can do.
because these zero out. Yes, it's x. Oh, that's not x squared.
2x.
That's 2x. But I don't have to bring it over because can't I just divide by 2?
That one is x equals 2? Why did I not get that? I got x minus 2 equals 4x plus 8. Because you would have to distribute 4 times x plus 2. And then you would get 4x plus 8. No, you wouldn't.
No, over here, these would both reduce.
Yeah, they go away. Yes, I got that. But, never mind. Never mind. She's
No,
done.
I want to know what.
No, it's fine. I'll just copy down what you got.
No,
That's not gonna help you learn anything. How'd you get 2x? Oh, because you're adding.
no, I'm trying to figure out what you did.
Well, I am too.
Okay, but don't. The attitude has to shut off, and we have to open up. That's why I'm trying to open up to what you're saying you did.
Okay, what I did, after you reduce them, you
Mhm.
have to do 1 times x minus 2, and then you have to do the 4 times x plus 2, and then it would just equal x minus 2 equals 4x plus 8. That's
Okay.
what I was doing.
Okay. This right here reduce it's x minus 2x plus 2, yes?
Yes.
And this common denominator over here would be x minus 2, x plus 2.
Yes.
So on both, I had to multiply by x minus 2, x plus 2 on both sides. So over here, the x minus 2 plus 2 reduces to 1, and you're only left with 4. Both of them reduce out.
Okay.
And over here, we have to multiply this by x plus 2, and this by x minus 2, and then this and this reduces out. Maybe I skipped the step of common denominators. Did that throw us off? So I don't want to skip that next time. Do you want me to go back and you guys watch me get common denominators?
I skipped this last one you did. Can I come up there and show you?
No, I know what you're talking about. It's what I'm asking
You
you.
did x minus 3 times the 1, and then you did
So you
x
have
minus
to-
5 times the x, and then we did it.
Okay.
So you have to
So I'm so
multiply.
confused.
Okay, so the last one we factor. Okay?
Yes.
And we said, oh, the common denominator over here is going to be x minus 2, x plus 2. I skipped this step right here. So when I do this, I have to multiply this by x minus 2, correct?
Yes.
And I have to multiply this by x plus 2.
Well, I thought you had to do it to the 4.
Okay, the 4 already has both things.
Okay. Never mind.
Okay, that's where we needed it. That's why I stopped. Yes, Emma.
So you multiply before.
Okay, I'm getting you can do it at one time. I was doing common denominators first.
So you can't add the 1 and 1.
No, they do not have common denominators. I cannot add them. After I multiply and get x minus 2 plus x plus 2, then I can add them. But I would do x minus 2, x plus 2 here. And x minus 2, x plus 2 here. I'm cross multiplying by these denominators.
So you multiply again.
Yes, because you have denominators. You can't have denominators when you're solving. It doesn't work. Okay, and then these would reduce out. And I would have 2x equals 4. So x equals 2. If your denominators on both sides are the same, are they always going to reduce out?
Yeah.
Yes, that's the whole point of getting the common denominator across the whole thing. Okay, so let's do another one. 5x minus 2 equals 7 plus 10 over x minus 2. Seven is over 1, correct?
Yeah.
So I said, get common denominators across the whole thing. So what would that common denominator need to be?
X minus 2.
What?
X minus 2.
X minus 2. So do we have it on the left? Do we have it here? Do we have it here? No. Do we have it here? Yes. So I'm going to have 5x over x minus 2 equals, over here, my common denominator is going to be x minus 2, correct? What do I need to multiply 7 by?
X minus 2.
So I need to multiply by x minus 2, which gives me what?
7x minus 14. Over
7x.
minus 14.
7x minus 14 plus 10. Because I already have common denominators, right? So I'm going to combine those, but I'm just not going to do it right now. So I'm going to cross multiply by those denominators, correct? So x minus 2 and x minus 2. What's going to happen to the x minus 2's? They're going to reduce. And I'm left with 5x equals 7x minus 4. Then what?
We would subtract the 7 out. Would we do that or no?
I don't care.
Yeah.
I would subtract 5, add 4, but
We would subtract. I subtracted 7.
we can subtract 7. That's fine. Subtracting 7 is more direct. So I get negative 2x equals negative 4.
Divided by 2.
Divide by negative 2.
Negative 2.
So x equals 2. That's the biggest thing about having the negative x. A lot of times people forget, and just in general, forget to divide by the negative. Did that help a little bit?
That already made it.
I mean, that's all you're doing. But I've got more. There's another one. X plus 6 over x minus 3 equals 2x minus 3. Or 2x over x minus 3. I'll let you try this one on your own. How's it going?
I keep factoring wrong. I realized what I did wrong. I forgot to put the x on the negative 3. So I just combined those. An accident.
You didn't distribute the x all the way. How'd it go for you, Gracie? Brandon, how'd it go for you? Or is it going?
It's okay. It's going okay.
Austin?
Alright.
I'm just making basic mistakes.
Well, basic mistakes we can fix. Sam, did it go okay for you? Did you find it? How about you, Coop? Okay, finding common denominators working okay? We got that down?
I was kind of already there, so.
Okay.
5 and 6 are easy on this. Are they?
Yeah.
They're easy.
I do. If I don't have much, if you guys are okay doing all of it today, I'd like to do it all today because then that gives us more time to go through things with graphing and stuff. But
5, 6, 10, 15, 13, 24, and that.
But I've got more. I mean, we're just going to go through these examples. That's why I was doing that today. Okay, so I have x squared over x plus 5 equals 25 over x plus 5.
Oh, that's easy.
Why is that easy?
Because x squared. Because they already have. Yeah, and they already have their common.
They already have the common denominator, so what's going to happen with the x plus 5? It's going to reduce out, isn't it?
Yeah.
So I have what?
X squared equals 25.
And you're going to take the...
Square root. Square root is the difference of squares.
Okay, so I get x equals plus or minus 5. Why plus or minus?
It shouldn't be plus or minus, should it?
When you take a square root of something, isn't it plus or minus?
Yeah, because it basically means negative.
Okay, plus or minus 5. But wait a second. When we have a fraction, should we think about what it can't be? Like, we have a problem when fractions, the denominator is what? 0. Do one of our solutions make our denominator 0?
What?
Would one of our solutions, we have positive, negative 5, would one of those make our denominator 0?
Yes.
Yes. Which one? The negative 5, right? It's an answer. Is it a good answer? No. So our answer is x equals plus or minus 5, but then we need to take and say x equals what? 5? Because is negative 5 going to be in our domain? Nope. That would be a vertical asymptote, wouldn't it? All that stuff comes back to haunt us, doesn't it? See if I can make it hard. I can't make it hard. Okay. This is what I would like to see. I know I gave you just 2 questions today. I would like you to try all of those, guys. There's really not that many. We probably did almost that many in our notes. Because that way tomorrow we could go over anything you needed to go over and we could get started early on our review. I'm not going to move the test up. The test is still going to be on Friday, but wouldn't it be nice to go through things at a little slower pace? Okay. So why don't we just put, actually I'm saying it right now. Monday and Tuesday's assignment is today. So 5, 6, 10 through 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 problems.